Hi, excited to be here. This is my first Big Sky Dev Con. I didn't realize I was the last talk, so the finale. I've enjoyed all the talks so far today. It's been kind of like a VIP audience, getting to watch all these talks. I'm learning some new things. I wish I would have had that leadership management talk probably before I became an engineering manager. Probably would have saved me some painful lessons, but yeah, so we're going to talk today about augmenting the web with WebAssembly and Web Components. A little about me. My name is Nick Kircos. I live in Missoula with my family and our weird dog. Previously, I worked at Storybird. I've worked at startups for about the last decade, and Storybird was a company I helped start. It's a storytelling for children. So I've basically been building stuff for the web for about 14 years now. And I say that because we're going to kind of talk about the history of how the web technology has evolved and the specs and what you can do on the web and how you can have a part of that in the future or now. Previously at Submittable as a web engineer there, and I just recently started at Onyx. And if you're looking for a job, they are hiring. So some things I do when I'm not working or playing with my kids are I like to figure out how you use Raspberry Pis. You got this tiny little computer, and what are you supposed to do with it? So one thing I did was I put it in my greenhouse, and it kind of controlled the fans and monitored the temperature and the humidity, and that's my daughter eating some carrots. And you know, that Alexa talk gave me some ideas. This is a smart mirror I built. I think I should add, some commands where I can do some mirror on the wall and start talking to my mirror. I think it would be kind of fun. So I love that these kind of talks kind of get I kind of build off each other. You kind of hear someone's, some technology, and it kind of spurs a new idea in your head. So I think I need to start adding some voice command to this. This was like a little widget I built to pull in the latest snowfall. So I like tinkering with kind of just technology. I found this picture recently when my parents brought a box of stuff back from Michigan, and it was kind of reminiscing on like what the internet looked like back in, I don't know when this picture was taken, probably late 90s, early 2000s, but in that corner, you can see the IBM Personal Computer 2, which was, I think, the beginning of the end for IBM in the consumer market. That computer didn't do too well, but it was my first computer and our family's computer, I guess. And that kind of, led to me getting a career in the web. And just like what the internet looked like back then. It was like a lot different, right? And we're kind of going to talk about that during this talk. And you can find me on Twitter and GitHub, and check out my outdated website if you wish. All right, so I'm going to do a little time traveling. It's 1995. What's going on in 1995? We got, this Windows 95. That's exciting. Clueless was a good movie. And the most exciting thing, JavaScript, launched with the Netscape. I think this is the Navigator Gold version 2.01. I don't know if this is the exact version, but that's what the internet looked like. And now the internet, the web had a programming language, and it was introduced by Netscape. It was developed pretty quickly, and over the years, people tried to kind of fill the gaps where JavaScript fell short. Notably, Flash and ActionScript and Java applets, if you remember that. When I started my career building stuff for the web, basically everything was in Flash because the open standards weren't there yet for the web. Like, you didn't have a video component. And if you wanted to play video on the web, you needed to use Flash Player. I guess like kind of an interesting aside there that I kind of learned through some research is there was kind of an abandoned version of JavaScript. It was, I think, JavaScript version 5. It was a proposal, and it was Macromedia, which became Adobe. It wasn't being adopted by browsers. Like Microsoft wasn't going to implement it, and it wasn't getting, like the standard wasn't moving forward. So they decided to implement the draft, and that became like the first version of ActionScript. And their idea was that they would build, the Flash plugin, and it would run. And then when browsers eventually implemented the JavaScript, you wouldn't need a plugin anymore. That's not how history turned out. And I think there was 5 years, I call them like the lost years of JavaScript, where there was no versions released. It's much better now. JavaScript is on like a yearly release schedule now, so you're seeing new features added. A lot less features than were added in 2016, where there was like, I don't know how many features, but a couple features a year come out now. And you can actually be part of that conversation, which is something I always kind of took for granted. I just assumed these things. I didn't really understand where web standards came from. Embarrassingly, for like a lot of my career, I guess, you just kind of learn these things, but like who creates these standards? JavaScript is an open standard, and you can actually make your own proposals. You can see proposals that are being made by others, and it's all on GitHub. You can actually be part of that process if you want. So, getting back to what this talk is about. What is Wasm, or WebAssembly? So, like I said, JavaScript was the language of the web for a long time. It's the only thing that ran in the browser for the most part, without a plugin. And it's not a new language, but it's a portable, pre-compiled, cross-platform binary instruction set for a virtual machine that runs in the browser, right? I'm gonna unpack that a little bit. That's a lot of stuff. So basically, you have support across the industry. This is kind of I think, unprecedented undertaking, all these companies kind of coming together to make WebAssembly and support it. Because you need to, when we get a little deeper, they're supporting all this different kinds of hardware and in all the different browsers. And when we kind of learn about what WebAssembly is, you'll understand why this is a huge effort by all of these companies. So it's not a language, but it's a compile target. So now you can compile Wasm for the web and more, not just the web. Like you might have heard in earlier talks, like you can run Wasm on servers and in Node. So this has some pretty big implications for how you write applications for the web. It provides a way to run code in like over 40 languages at near native speed in a web browser, right? So this is just a short list of some of the languages that you can compile to WebAssembly, C++, Python, Go, and Rust, like you heard about earlier, and plenty more. How is this possible? So there's different tool chains that allow you to compile to Wasm. Emscripten is kind of the most popular and most powerful one. It was built on another open source technology, LLVM, which the goal of that project was to make code more portable across different kinds of hardware. And the original goal of Emscripten was not to compile WebAssembly, but to compile C++ to ASM.js, which is like a version of JavaScript that you can't read. I guess it's for robots or something, but it's a highly optimized version of JavaScript. And all that work that they did getting C++ to compile to ASM.js, they were able to leverage to build a compiler for WebAssembly. And Emscripten is actually doing a lot of the heavy lifting for these languages. If you're writing a library in C++, you have a lot of I/O. You have like a file system. Emscripten is actually, like you heard in previous talks, it's bringing everything you need to that binary. So it's going to emulate file system. It's going to basically try to do everything it can. It's meant to be a drop-in replacement for C compiler, and so you don't have to do much intervention. And why does this matter? So previously, you'd have to, if you wanted to use something in a browser, you'd have to port it to JavaScript, or not run it in the browser, right? Make some server-side service that you call through some API. But now you have basically a huge amount of libraries. You can take all of these existing code bases that are written in all these different languages, and you can compile them and use them in a browser. And you can use them in Node. So this is just a quick search I did on NPM and for just Wasm, right? And there's almost 2,000 packages. So this isn't just an example of how you would import a Wasm module and use it in Node. And it was released in 12.3, I guess, as an experimental feature. And you can see here it's pretty straightforward. This example is a compiled artifact, and they're calling this add_to function on it that was exposed. So the NPM part of this is exciting. The Node part of this is exciting, and NPM. So you've probably run into this before. I ran into this on the job the other day. There's a lot of packages on NPM that will either try to compile or have platform-specific binaries, and they are kind of tough to work with. Sometimes they'll just fail to install, right? So for example, we were trying to use Canvas, and Canvas is like a mock of the HTML canvas for Node, and it was failing to. It didn't have a binary for the specific Docker image we were using or something. So instead of packaging or having a ton of different precompiled binaries for all of these different platforms and processors, you could use WebAssembly, and now you have a portable binary that's going to work across all hardware. libsass was another one that I've run into in the past that kind of gives you headaches. So does this mean the end of JavaScript? I've heard about WebAssembly. I don't know when exactly it was introduced. I think 2017 or 15. And at first it was like you can now write C++ for the internet. And I was like, well, I don't want to learn C++. That sounds way harder to write things. Some people are kind of going that direction. You can write interactive UIs without touching JavaScript basically at all, using Microsoft's Blazor framework, right? This is C#, and this is going to get bundled up, and there's going to be a C# runtime that gets bundled up in that Wasm file, and it kind of does a bunch of magic behind the scenes, and you're going to be able to, kind of like this is the holy grail of web development, right? This kind of, you write code in one language, and it runs on the server, it runs on your browser, and you're not maintaining multiple code bases. This is what people have been trying to do and have successfully done with Node and using JavaScript, but now you can do this with other languages if you want, at your own. But I don't think that's like the major use case we're going to see. Who knows? But I think JavaScript and WebAssembly really complement each other. Where there's shortcomings in JavaScript, maybe you can find the solution in a different language, and now you can use that on the web. These are some notable examples of things that were moved into WebAssembly. So this is AutoCAD. It's a 30-year-old code base, and they were able to get it running on the web. which is pretty impressive. So 3D gaming libraries like Unity runs in, now they can compile and they can take advantage of getting closer to the hardware, and they get pretty good performance out of shipping games and running them in WebAssembly right in the browser. Google Earth used to only run in Chrome, and WebAssembly enabled it to be portable and run across all major browsers now without plugins. And other than just porting giant code bases, you can kind of find out where there's gaps in web technologies. So eBay used WebAssembly to create a barcode scanner in their app so that you could scan barcodes and quickly pull up products. So that's kind of just like a very niche feature that they wanted to have, and they were able to implement it using WebAssembly. And I'm imagining they were just using existing barcode library. I'm sure they didn't write a new one. So this was an example from my job at Submittable. We build a lot of forms, and we had this one feature we wanted to build where you basically had a spreadsheet type of input for a website. So you want it to work like spreadsheets people know, like Excel. So there's no good real spreadsheet library in JavaScript, but there's plenty of libraries that handle Excel and doing all of the different formulas and evaluation in other libraries. So this is XLNT, this is a C++ library, and that's how you would use it there. And I did a quick search on NPM, and of course someone has already compiled it to WebAssembly. And this is just an example of how you would use it in JavaScript. So you create this new workbook, and you can grab a cell, and you can set values in cells, and you can prompt a download of a Excel file so that people can download the work they've done and delete it. It's kind of incredibly powerful just to bring this in and use it directly in JavaScript. The way we ended up implementing it was through a service where basically we'd send everything over the wire through an API, and it would calculate all the formulas and values and send the response back. But if you wanted to, you could do it all on the client in the browser. So where is this supported? It's supported everywhere, basically, now. It runs in all major browsers across all operating systems and a node. And that really goes back to like that collaboration between all those major companies, right? This is a huge undertaking for WebAssembly to be able to run basically on your phone, in your browser, on tons of different hardware. They're able to support WebAssembly. All right, some pain points. So should you start writing everything in WebAssembly? Probably not. There's code splitting is difficult. That's fairly easy to do these days in JavaScript. Debugging is a little challenging for compiled WebAssembly. You're going to have to do interop between JavaScript and whatever functions you expose from your WebAssembly. And I didn't actually check on the status of this before I made this slide, but the Chrome conference from last year, they said they were working on supporting multi-threading and garbage collection. So a lot of existing libraries, to support parallelism and use multi-threading. So if you wanted to compile a program that utilizes multi-threading, you would run into limitations there. A lot of these are like compression algorithms. I mean, it's used all over the place, and we've kind of gone over some use cases, but I think there's a innumerable number of use cases for this. You can record and encode audio and encoding video and doing 3D rendering in the browser. and compressing images or doing stuff with PDFs, doing physics simulation, all kinds of stuff. I used to make games for the web and use Box2D, which was a C library or C++ library, and of course people have already ported it to JavaScript, but there's already a WebAssembly of Box2D that you can also utilize, which is a pretty fun 2D physics engine. You probably know from Angry Birds. All right, so on to the second part of this talk, extending the web with web components. So what are web components? So this is a new set of APIs that you get that allow you to create custom, reusable, and this is really important, encapsulated HTML and styles that you can use in web pages and apps. And it's an open standard, and they will work across all modern browsers and with any JavaScript library or framework. And I'll kind of get into more of that. So this is a custom element. You all know the HTML elements you know and love. You got divs and image tags and all kinds of stuff, selects and inputs. Now you can basically create your own components, elements for the web, name them what you want, and under the hood you can do whatever magic you want to do. So this is how you do it. It's pretty straightforward. You extend the HTML element class and you define it in the window, and then you can just use it. So getting back to that encapsulation, this is important. For web components, all of the, everything, all the guts of it are encapsulated in this shadow DOM, and that DOM is separate than the DOM on your page. So you're not going to get conflicts. It's not those elements in your shadow DOM aren't going to get styles from your style sheets. So this is what makes it more portable. It's kind of like a little sandbox where you can do whatever you want. And this is the dev tools. You can actually inspect and see what those shadow elements are. And we'll get into more of what you're actually seeing there in a little bit. You also get a new API to create templates. This is a fragment of a markup that you don't render when the page loads, but when you need them. You've probably seen this problem solved through handlebars and mustache and jQuery templates and a million other ways people have been doing that. Now it's a standard on the web, and if you use Vue.js, they kind of do a very similar thing. And there's a lot of libraries that help you kind of remove some of the boilerplate that it takes to kind of create these web components. One of them is Polymer, and if you're familiar with React or Vue, even it looks pretty similar. You're just creating this simple greeting element, and you have a property on it that gets bound, and at the bottom there you can see it's being used, and it's just returning a paragraph with a hello. So here's some examples of web components that are out there. GitHub uses a lot of web components. You can inspect your GitHub's repo and kind of see what is a web component and what's not. These are some time elements that they have. You can use these. These are open source to deal with kind of common stuff you do with dates. So this is showing a local time from a date stamp there, and then you also got the time ago. So you can see how these can be pretty helpful in kind of changing how you display dates in time. Web components are great for design systems. This is Material UI as web components. Someone made a wireframe looking elements. So you can make some kind of wireframes and web components if you wanted to. And this is where things, I think, kind of get interesting for me, where you can take something as simple as, you want to display a GIF, and, they're kind of annoying on the internet because they just keep playing and they never stop. So I can't remember who made this, Glenn Matterhorn, I think. Actually show you. He made a web component that takes any GIF and has some additional properties you can set. You can change the speed of it, you can change how many times it plays. So you can see it here. He's got it ping-ponging back and forth. You can have it playing a certain amount of times, and then you can, speed it up or slow it down. So I thought that was a pretty cool use of web component. All right, some use cases for web components. Like I mentioned design systems. If you're thinking about creating like a design system component library for your company, you might want to consider writing it in web components. It's going to be portable, and it might outlast maybe the library you're using at the moment to do your, your web development. You get to basically create your, you can extend that standard set of web elements that you have out there and create your own. And a use case, I haven't seen this, I'm sure someone's doing it, but I could see it, you can use it as an alternative to using iframes for embedding content. And there's probably a million other use cases I can't think of. And the real cool part about this is you can use it anywhere you can render HTML. It's not limited to a library framework. They work, you can use web components in React and Vue and Django and Rails. As long as, if you can output HTML, you can output a custom web component. And it's supported all over the place. And there's a little asterisk there. There's some inconsistent implementations, and the spec was kind of evolving, so there's like a million libraries that make building web components easier. All right, back to WebAssembly and tying this stuff together. ImageMagick, this is another program that came out 30 years ago. And now it's time for a demo. So I saw a talk on WebAssembly, and the demo was they got ImageMagick to work in the browser. And I thought, well, that's cool. Wouldn't it be cool if you could take the power of ImageMagick and just make a nice interface with a web component and just be able to use it, just point it to any image and basically provide the command line arguments you would to ImageMagick, but in the browser. So what does that look like? Here is, make this bigger. So this is a demo. At the top here, I don't know if I should make this even bigger so people can read it. At the top here, we just have your regular old image tag. And a little farther down, you have the ImageMagick web component. And this is calling this convert, and it's using the paint filter with setting 5, right? And you go down a little farther, and you got this image, and it's using the swirl filter. So you can go in here and edit it like a normal, any other element in your web page. And I don't know if you noticed that, but now it's swirling 180 degrees. There's another filter down here. But basically everything, the way I wrote this is it just takes this command attribute and it passes what you would normally pass as command line arguments into the WebAssembly ImageMagick module. And it does what it would do on your command line, but in your browser. And returning that, and I'm setting that results is in the shadow DOM here as the source of that image tag. So you get some pretty powerful stuff. And if you saw, like, the performance is pretty fast. Like, you can run manipulations on images rather quickly. So what does that look like? Here's the package. We can take a quick look at the code here. you basically just, well, actually look at how it works. It's pretty simple. All right, so I used lit element or light element, I don't know what it's called. And I basically am importing my WebAssembly ImageMagick package here. I'm setting what properties I want. These are going to be the HTML attributes you can interact with. There's some styles, and these are encapsulated inside the inside of the web component. They don't leak out to like the global scope, so you're not going to, change how images are rendered on the web page for everybody else. There's a constructor where you set some defaults. There's this attribute changed callback. This is part of the library where you can kind of listen to make those attributes responsive for when the values change, what you want to do. So anytime the command attribute or the source attribute changes, I run this convert image. And what I do there is I just pull out the source, the original source. I fetch that image. I put it into an array buffer. I pass it into this call function is actually the one that was exported from ImageMagick. So that's calling ImageMagick. I'm splitting the arguments and just kind of formatting them for how it wants and putting the image in there. And I'm just awaiting that call. It's an asynchronous call to WebAssembly. And when it's finished doing its image conversion, I just set, this is doing some memory cleanup. I'm just setting that attribute. So I create an object URL, and this basically makes that source like a file that you have access to. And I'm setting it on the converted source attribute, which if we go down to this render function, if there's a converted source, which is that, the output of ImageMagick, it sets it as the source of your image tag. So it's pretty simple. And this giant block of text is just an SVG spinner. So that's not really interesting. And at the bottom here, I'm just defining it on the browser. And basically, that's it. It's this whole, I don't know what this is. I mean, it's 100 lines of code, and I don't know, over half of it is SVG. So I was able to take, this 30-year-old library, surface it as an element that everyone knows how to use elements in HTML, and just kind of make this really simple interface. I think it kind of demonstrates the power of, web components and WebAssembly. So I guess takeaways, I'd say it's a tool that you have. You can utilize it to take programs from many languages and draw on this huge catalog of existing applications that are out there and use them in Node or in the browser. And it's not meant to be a replacement for JavaScript, but some people might use it like that. And you don't need to know C++ to use WebAssembly. And it's just, I think it's awesome that this these open standards are moving, technology forward. Like you can do some crazy things in the browser now. And like, what is the future? Like, is there going to be a day where you're not downloading native apps anymore at all because everything can run at native speeds in your browser? Like, why would you need to download a platform-specific binary anymore? Who knows? I mean, you see this a lot now. A lot of things are web apps that used to be downloadable applications. And some takeaways for web components. You can extend the web with an API that's familiar, and you aren't locked into a framework. You can build your component library in React or Vue. It's great. It's not going to be as easy to for other people to use if they're not using that framework. And it's truly encapsulated in portable code. And so I hope, I don't know, it kind of sparks some ideas that you can go kind of make something awesome with these new tools at your disposal. And I'd encourage you to share it. I was the first package I've ever published on NPM. And, I was like, how do you do this? Is it really complicated? It turns out you just have to have a package JSON, and you just type npm publish, and it goes out for the entire world to be able to use. I'd like to thank my fiance, Courtney, and my family. They let me borrow that van so I could get here, and that's where I parked last night and made these slides, and I'm a little embarrassed at the design of them. I did go to school for web design, for graphic design, and my slides are a little sloppy. And I wanted to also give a shout out to Kaz Perch's talk on WebAssembly. Their talk kind of inspired this talk. I wanted to take it like a little further and dig deeper, and I found it really interesting. So I kind of piggybacked off that. And now I'm ready for questions. Thanks.
All right. So I was interested, what kind of interopt issues have you run into between the language that you're writing in and the browser, or as you're compiling towards the browser as a target?
I haven't actually compiled to WebAssembly myself, but I didn't really talk about it much, but there's this layer of like exposing functions from those libraries to JavaScript. And so that's kind of like this layer that you'll have to kind of, create this API and this interface of how you're going to do that interop and what methods you're going to expose to JavaScript. But once they're exposed, it's basically like calling a function in JavaScript.